Hey guys, I hope that I'm live right now. If you are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Good evening, everyone. Good evening. No issues. Okay, great. We'll wait for 5 more minutes so that everyone is able to join us, and then we'll start off with our today's class. Okay. Good evening, everyone. Good evening. In the meanwhile, if you guys have any questions or any queries, please do let me know and I will help you guys out. Okay, we are just waiting for everyone to join us. In the meanwhile, if you have any questions, any queries, please do let me know. Okay. Hello, everyone. Hello. So I think so. My voice is a bit coarse today, so please excuse me for the same. Okay. Sure, Ajay. Thank you so much. Guys, if you have any questions, any queries, please do let me know. So how can we do loop coding in Python like we do before in some languages, if else loop? Okay, so if else is not a loop, if else is a conditional statements. Okay, you are having your for loop, while loop that exists in do while loop that exists in Python. So of course you can just do a little Google search and you will be able to know about that. Okay. You guys have any boot camps related to computer vision? We will, of course, have some boot camps related to computer vision. We just have one on OpenCV before this. Okay, so in the future as well, yes, we'll be having some. You don't have to worry about it. The next one is in the backend web development arena. We'll be learning how to create a Node.js, MongoDB server, and the application that we'll be building would be a simple login, logout page. Okay, that will work as well. That is what we are planning for the next boot camp. Tomorrow we'll be having a bit of theory still left. Today we're trying to cover the entire theoretical portion. Tomorrow we'll be having 2 hours of classes most probably. So please be ready for the same as well. Okay. Tomorrow we'll be having almost 2 hours of classes and we'll try to finish off the project tomorrow itself. So please be ready that tomorrow there will be 2 hours of classes. Okay. Okay, great. Anything else, guys? Do you have any questions, any queries? Please do let me know. We'll be starting from 7 itself, Diksha. Okay, that is our time, and we'll be going up till 9. So 7 to 9 would be the same. Django is used for backend development in industry, yes. So YouTube that you're currently using as its backend in Django. Uh, anywhere which deals with videos, any application that deals majorly in videos itself would have its backend made in Django. Now, you guys need to understand that when I speak that YouTube has its backend in Django, that does not mean that the entire backend of YouTube is made in Django. Only some of the applications are made in Django. Okay. Now, backend web development, you don't have a single backend that maintains the entire website. Okay. So, for example, for YouTube, you will have one backend just for login, log out. That is the authentication server. Then you will be having another backend that is just for the payment. So that will be the payment server. You'll have one backend that will be just for video processing. That would be your video processing server, and so on and so forth. And these servers exist independently and talk to each other to maintain the entire stuff. So every single server can be made in a completely different language. So maybe the authentication server would be in Node.js. Maybe the video processing server would be in Django. Maybe the payment processing server would be in Go. Maybe some other processing server would be in another language itself. Okay. So all these servers exist fundamentally in various different languages depending upon what task they are performing. But in the industry, almost 80% of the backend is done in Node.js and MongoDB and Express, and almost 80% of the front end is done in React. So 80% of the web basically works in the MERN stack. Okay, MongoDB, Express, React, and Node. That is called as the MERN stack development in web development. So usually, when I suggest students, if you're going with data science, okay, if you are if you have decided that I will be pursuing data science itself, I don't want to do full stack, and in that particular case, you want to learn backend web development, then go further with Django or Flask. Okay. Whereas if you are a particular person who is like, no, I want to focus upon full stack development, then go with MERN stack. Don't go with Django. Okay. Afan, see, according to my understanding, some of the students get free from the college at 5:30 and 5:45. So they come at home at 6:15, 6:20. It becomes very difficult for them to join on time. Okay. No, Manvi, you don't have to learn all these different frameworks. You just have to learn one framework thoroughly. Okay, for example, you are proficient in MERN stack. Okay, you're proficient in MERN stack, you're proficient in AWS, you're proficient in DevOps tools like Docker, Kubernetes, maybe Travis, CI/CD. So all these things you are proficient in. Now, when you are joining a particular company, these concepts get covered, right? So for example, my company is currently working in Django. Let's assume that, okay, you are a MERN stack developer, you apply to my company. Okay, so I will take you up, I will hire you, because in a particular company can have its very own framework as well. For example, my company has built up its own web development framework from ground up, so I cannot expect anyone to learn it. So anybody who's having the entire knowledge about full stack web development, even if I don't use the same framework as a company, I will still hire them because they have the fundamental knowledge. I will give them 1 week of training and they will be able to work with my stack as well. So that is the main thing. You need to know one particular stack in its entirety, and then the concepts are applied to another stack as well. Okay. Okay. Anything else, guys? Please let me know. Exactly. Concepts and some practical knowledge is extremely important. So now I don't say that by concepts I mean theoretical knowledge. Practical hands-on knowledge and understanding about the entire how the web works is exactly very important. Okay. Let me just mute my phone, otherwise it will keep on ringing. I'm so sorry. Ankit Tripathi, in your course, do you guys provide placements in AI ML field? See, again, there's no AI ML field. Okay, the as a so you would either be placed, for example, if in data science, if you are considering your placements, you'll either be placed as a software engineer, okay, or as a data analyst or as a data scientist. So these are the three placements that we have provided. So for example, we got almost 600 software engineers placed, 100 got placed as data scientists, and 200 got placed as a data analyst. So that is usually how, like, what were our statistics in the placement department in data science. Out of the 1,000 students, we got around a 950 students placed up till now. 920 students placed up till now. Yeah. No, we are not going to use OpenCV for this. Okay, we are going to use TensorFlow, if you guys are familiar with this. Okay. Um, Okay, there's nothing called as machine learning AI developer. I think so. I went through the entire stuff about like the jobs that are available and what you have to study for them as well. There's nothing called as a machine learning AI developer. Yes, for getting placed as a software engineer or a data analyst or a data scientist, you, and while learning DSA as well, the minimum time is of 3 months. That is the bare minimum that time that it would take. And if you're doing it on your own, it will take you about a year to complete it. Okay. Okay. Usually, the certificates for a boot camp are sent after 1 week at the end of a particular boot camp. Okay, we take at least 1 to 2 weeks to basically go through all the projects and check whether they are correct or not. Okay. Thank you so much, Ifan. Provide the date along with the certificate, it will be good. We'll take that into consideration, but actually we don't provide the certificates. The certificates come directly from Microsoft and Google, so we have no say in that. We just send them the list of the students that need to be like send the certificates, and they just send the certificates from their end. Okay. I think so. For the Amazon bootcamp, these certificates have been sent, Sabrina. Please check for your promotional emails as well. Sometimes the email gets landed up to the promotions page. Okay. So if you have submitted the project and have the correct attendance, you might be able to get the certificates. So let's start off with our today's class. There's a lot of theory that we have to deal up with today. Okay. Okay. So let me just open up the live chat as well so that I'm able to see what you guys are talking about. Okay, so certificates have been received. Okay, great. Okay, so let's see right over here. We have previously talked about different like companies that are there. Okay, so different machine learning models that are there, the algorithms that are there, the types that are there. One of the subtype of machine learning is your deep learning or your neural networks. Okay, now back in 1950s, okay, back in 1950s, some of the scientists came to, so somebody's asking, what do we have to become a developer in AR, VR, XR? Have you done DSA? First complete that. Okay, so this is something that, see, don't follow anything blindly, that you're able to see the hype for like blockchain, the hype for AR, VR. The total number of blockchain jobs currently in India is less than 1,000. Less than 1,000. For AR, VR, you could easily count them on your fingers. My major concern with this is, see, it is possible that you are one in a billion, but the probability of being one in a billion is really very less. See, I'm not here, I'm not a YouTuber. I'm not here to like promote some dream that you could follow, the dream life that is there. I'm here just to show you a mirror that this is the harsh reality of our country. These are the jobs that are available. And if you are planning to get into a job, this is what you need to do. that's the harsh reality. Like, yes, I could get into MIT as well, not Manipal Institute of Technology, Massachusetts, or like maybe Stanford. Okay, I maybe Harvard, but I didn't even get into an IIT. How the hell I'm going to supposed to be in a Stanford college in my BTech years? So don't make up false hope, false dreams. Don't even follow that. Just first get into a good company, and if there are any AR, VR, XR projects right over there, they will train you. They will put you up for that particular role. But up till then, my suggestion would be get a job first. Okay, Nabil, that is for you. Deep learning. Okay, so back in 1950s, the scientists, the researchers that were there, who were researching about machine learning and AI and all these kind of stuff, they thought of one particular aspect. So what I'm trying to do is I'm trying to create a artificial like entity that is able to do the exact same things that humans are supposed to do. That was their aim at the end of the day, at that point of time. So, what gives human beings their intelligence? Can someone let me know? What is the particular stuff that gives humans their intelligence? Can somebody let me know? What is the particular stuff that gives humans their intelligence? Exactly. So the answer that they also came into being is brain. Okay, brain gives humans their intelligence. So what can we do right now? So as a researcher, they said that okay, let's try to recreate brains. Okay, let's try to recreate a model of brains. Okay, that is artificial. We need to create an artificial brain. So they started exploring brain. They started trying to understand brain, and then they tried to reach out to neurologists. Okay, they try to reach out to neurologists, some of the biotechnicians that were there, and try to understand how brain works. Okay, so they came to some of the like they tried to understand. So can you let me know what is the basic unit of a brain? Like, what is the smallest aspect of a brain itself? Can somebody let me know? Can somebody let me know, guys? Nerve or neurons or nervous cells. Okay, so neural cells. So all these kind of stuff. So they started exploring it. They started looking at neurons, and this is what they were able to see. Okay, my drawing is not that great, so try to pardon me for my drawing skills. Trying my best so that you are able to see a neuron itself. So they were able to see something like this. Okay, this is how a neuron looks like. Okay, right over here, this is how a neuron looks like. So what they were able to see is a neuron works in a very complicated manner. Okay, electrical signals are passed through the dendrites right over here, the tentacles that is having it is electrical signals are passed from various different neurons, maybe some muscles, maybe some other parts of the body as well. These electrical signals come to the neuron. Okay, that is the nucleus of the neuron itself. Some type of computation happens in the nucleus. Okay, some type of computation happens, a new signal is generated, and this new signal is then propagated further on through the axon to the next neuron, or maybe a muscle, or maybe something else. Maybe it needs to be passed on as another message. It needs to be passed on as an action to be performed by a particular muscle. So that is how a neuron functioned. Okay, you got input, you did some processing, and then you got output. Okay, so they tried to create this mathematically. So what they did was, okay, so let's create this mathematically. We are having our nucleus. Okay, there's some computation happening right over here. We have got our inputs. Okay, we are going to get our input, let's say x1 and x2. Okay, and then some computation happens right over here, and we get our output, that is your y. Okay, so they try to model this after that. So you are having two variables right over here, x1 and x2. If you are having two variables right over here, can you tell me in mathematics what would be a mathematical formula, a mathematical expression for two variables? Like that's the basic question I'm asking. Everybody should be familiar with this. What is the mathematical formula, mathematical function of two variables? What is f of x1 comma x2? Or let us say what is x of x comma y? Okay, this is called as function in two variables. What is the function in two variables? You have already studied this in Python, sorry, in mathematics. So what is a function in two variables? Can somebody let me know? Can somebody let me know? If you don't know, you can tell me that as well. Like this is something that you have studied in your sixth standard. I'm talking, this is a function in one variable. A of x plus b is a function in one variable. I'm talking about a function in two variables. Okay, so a function in two variables is, you are very close, Yogesh, but you have to complete it as well. Ax plus by plus c. That is your function in two variables. Okay, you were very close, but this is the function in two variables. Please try to remember these are mathematical stuff. Okay, everything. So for those who are like, yeah, who is going to ask this in the future, you are going to learn everything that you have used up till your 12th standard in mathematics if you want to pursue a career in data science. Okay, everything would be important. So what they did was they created a artificial neuron. Okay, this is a single neuron. So x1, x2, you are having your c right over here. Okay, call as x naught itself, and then you're having your output y. So y is equals to x1 w1 plus x2 w2 plus x naught. Okay, that is the same as saying as ax plus by plus c. Okay, so you are having the input as x1, the input as x2, the input as x naught, and you have the w1 w2 as weights. Okay, so this is the weight assigned to x1, this is the weight assigned to x2, and the weight assigned to x naught is 1. Okay, so what you're currently doing is, the first half is basically you are adding these things up. Okay, you are adding these things up. So x1 w1, okay, plus x2 w2 plus x naught into 1. Okay, you are adding all these stuff up. So that is the first thing that a neuron does. Neuron, the first half of the artificial neuron was a, so this symbol, you guys are familiar with this symbol, am I right? You are familiar with this sigma symbol? Guys, are you familiar with this sigma symbol? Please let me know. Guys, are you familiar with this sigma symbol? Please let me know. Please be a bit quick in letting me know as well. Great. Sigma basically means whatever is coming from right three paths, add them up. Okay. So we are adding them up. X1 W1 plus X2 W2 plus X naught is equals to your Y. Okay. Is equals to your Y. Now the second particular part, the second half of the neuron is called as an activation function. Okay, the first half of the neuron is a summation, that is the sigma symbol. The second half of a particular neuron is your activation function. Now let us try to understand what do you mean by an activation function, and we'll look at some of the activation functions that exists as well. Okay, let me just delete everything from the screen. It's not important. Okay, so let's try to understand what is an activation function. Let's say that you are currently making a, like, your end goal is to get the rent, sorry, the pricing of a house in a particular area. Okay, your goal is to predict the pricing of a house in a particular area. Can somebody let me know if the pricing of a house can be negative or zero or something like that? Can it be possible that the price of a house is negative? Can somebody let me know? Hello guys, can somebody let me know? Can a price of a house be negative? No, absolutely not. A price cannot be negative. Okay. But if you consider the y is equals to x1 w1 plus x2 w2 plus x naught, this can be negative. This particular equation can be negative as well. How to make sure that the answer y is never negative? Okay, so what you do is, whatever this is, you call this as f of x1 comma x2. Okay, you call this as f of x1 comma x2, and you pass this into another function called as g of x. Okay, g of x is called as an activation function. One of the activation functions is the ReLU function. Okay, one of the functions is the ReLU function that looks something like this. So whenever the x, okay, whenever x is negative, okay, the answer is always 0. Okay, whenever x is negative, the answer is always 0. As soon as x becomes positive, okay, the value is y is equals to x. Okay, as soon as, so basically ReLU function is, if x is less than 0, then 0. If x is greater than equal to 0, in that particular case y is equals to x. This is g of x, that is the ReLU function. So if you are feeding f of x1 comma x2, whatever the value is, maybe 100, maybe 200, maybe minus 100, into this particular function, that is your ReLU function, your answer can never be negative. Are you guys able to understand? Your answer can never be negative. So this activation function is what ensures that your output is what you expect it to be. Let's say that you want to bring out the probability, you want to find out the probability that a particular person might survive in Titanic. You want to find the probability that a particular person might survive in Titanic. So what would be the function that you should be using? The first thought in mind is its probability. Probability can only lie between 0 and 1. Okay, probability can only lie in between 0 and 1. It can never be negative, it can never be greater than 1. So which particular function should we use to find out the probability that a particular person is going to live or die? Are you guys able to understand? So the probability, for finding out the probability of a particular stuff, the activation function that you would use is a sigmoid function. So sigmoid function looks something like this. This is 1, this is 0, and this is 0.5. This is how a sigmoid function looks like. I don't remember the exact stuff on how the formula of sigmoid function goes as, but I think so it is like 1 divided by 1 plus x to the power 1 by x or something like that. So that's the sigmoid function, but I don't remember it. For example, this is the function for ReLU. I don't remember the mathematical formula for sigmoid exactly. It has been very long for me as well. Okay, but this is how it looks like. So whenever it is 0, it tends to, the answer tends to be minus. So for example, whenever it's negative, the value of x is negative, the answer tends to be in towards 0 itself. Whenever x is positive, the answer tends to be towards 1. It cannot be greater than 1, it cannot be less than 0. Okay, so it's between 0 to 1. So this is how you will be using it. You will be using this particular sigmoid activation function whenever you want the answer to your question, the answer, the output from your neuron to be a let's say to be a probability itself. Okay, so there are various sigmoid functions that exist: step function, ReLU function, sigmoid function, tan h, cos h. So there are a lot many functions that exists. E to the power minus x, yeah, that's absolutely correct. It was 1 plus e to the power 1 by x. Okay, so that was the function, sigmoid function. Okay, so you guys need to remember this thing. So the first step of a neuron is your sigma, that is addition. The second step is applying a correct activation function according to your need. Are you guys able to understand up till here? Please let me know. Are you guys able to understand up till here? Please let me know, guys. Guys, please let me know and be a bit quick in letting me know as well so that we can continue further on. Okay, great. So let's move on to the next stuff. Now, as you're able to see this single neuron that we were having, okay, so it basically the neuron F would be equal to G of, that is the activation function of x1 w1 plus x2 w2 plus x naught. Okay, so that is basically the entire stuff that we have. Now the range of values, and so we are only able to have like two inputs right over here. This is a bias function, so it's not an input at the end of the day. So you're having just two inputs that you can take into the neuron. There's not a lot of different things that you can do. Your single brain cell, a single neural cell in your brain cannot do anything. It's just dormant. It needs to talk to other neurons. It needs to be able to get, like, your brain has billions and trillions of brain cells inside of it. So you need to do that same for this neuron as well. You need to group neurons together. You need to combine neurons together so that instead of just making a simple formula, it can do complicated mathematical formulas. It can generate complicated mathematical formulas that it can use to produce the results that you need. And that is where the concept of deep learning came into being. And the first deep learning that was created was called as ANN, or artificial neural networks. The first usage, the first practical usage for this was used, I'm not talking about something like that is in military or something like that. First openly public use of ANNs was done in banks. So you must have seen that whenever you are filling up a checkbook, okay, whenever you are filling up a checkbook right over here, there are some letters, okay, you write 7, 8, 9, all these letters are there. So that is handwritten letters. So the capability of inferring that, okay, when you are writing 7, this 7 actually refers to the 7 number. It's somebody would like 7 as this, somebody would like 7 as this, somebody would like 7 as this. Okay, so to be able to understand that all these three means the 7 number itself, okay, means the 7 number itself, that is what the bank needed. The bank needed that if I'm putting up, if I'm scanning a particular handwritten check, then in that particular case, I should be able to know the numbers that are there. Okay, so that is where the first implementation of ANNs was done. So I haven't decided upon the project that we would be doing. If you guys want, we can make this particular project as well. We can create a, like, you can upload the 7, like you can write a particular number, you can upload it and it will just tell you which number it is. If you want, we can do that. If you want, we can make a classifier between dogs and cats. Okay, so that to identify dogs, to identify cats. So if you want, like, tell me, I will adjust the project according to that. Okay. ANN was initially the first open use of ANN was done for character recognition itself. Yes. Okay. Okay. So what does ANN mean? How are we able to branch neurons? How are we able to combine neurons so that it is able to make more complicated predictions? Okay. That is the question right now. So let us look at that as well. So what did the researchers do? The researchers were like, okay, we will have multiple neurons. Okay, we'll have a layer. Okay, we have a layer of neurons right over here. We want an ANN project. Don't go forward with an ANN project. If you want, we can do an ANN project as well. I have no objections. It would be easier for me as well. Okay, if you want, we can do an ANN project. If you want, we can do a convolutional neural network project as well. So tell me right now, do you want a CNN project or an ANN project? Because according to that, I will teach it right now itself. Okay. Do you guys want an ANN project or a CNN project? Don't do an ANN from scratch. Yes, you can do. I've already done that. Okay, in my college days, it took me almost a week to complete that project. You can do it, but never do it. Okay, nobody is expecting you to know how to implement ANN from scratch. Okay, so we'll do CNN itself. According to me as well, CNN is much more appreciated. Both Yogesh is out of his senses. We only have 2 hours. Okay, okay, CNN would be a better option. So let's try to understand. So what they did was they created a layer. Okay, they created a layer like this in which they fitted neurons right over here. Okay, and once I fitted it up with neurons, they provided it with the input. So this is the input right over here. This input went into each of these neurons. Okay, each of these neurons received the same input. Okay, now and the bias as well. So they provided the input, they provided the bias. Then again, so this input can be like various inputs can be there. Let me just show it to you. For example, you are calculating the cost of a particular like house in a particular area. So one of the input might be the number of residents in that area. Okay, the number of BHK, the size. Okay, maybe the locality, maybe like let's say the society, and so on and so forth. So there can be multiple inputs that are there. Okay, what is the temperature in that city, how many schools are near to that particular city, how far is the nearest hospital to that particular home, okay, and so on and so forth. So all these particular inputs were given to the neurons. Okay, so let's use another color. All these inputs were given to these neurons right over here. Okay, each of these neurons received a lot many number of inputs. Some of them received all the inputs, some of them received some of the inputs, and so on and so forth. Once that was done, they created another layer. Okay, all these inputs, all these, like there may be like 13 different inputs right over here, and there will be like almost 512 different neurons in this particular layer. They created another layer after that to increase the complexity, to increase the computational power of the ANN itself. Okay, now the output for these neurons, the output from the first layer of neurons were fed to the second layer of neurons. Okay, were fed to the second layer of neurons like this, and so on and so forth. The input was fed to the first layer, the output from the first layer first as the input to the third layer. Now the answer that you want is just one particular stuff. That is the output and nothing else. You just want the output. So what they did was you just have one output, and they connected all the different last neuron layers to the output itself. Again, this will have like 512 or 526 neurons inside of this particular layer as well, and the output would be stored in a singular neuron. Okay, so they passed in the data, they checked, they performed the training, they performed the testing, and they got the answer at the end. This is how they were able to increase the complexity of the neural network. Just think about it. You are having almost more than 1000. Okay, you are having more than 1000 neurons that are currently there, who are generating mathematical equations and using those equations as inputs and outputs and continuously conversing with each other. Okay, Keshav, I'm going to block you from the live chat. Please do not spam the live chat if I'm seeing it again. The only mode of communication that is there in the bootcamp is in English. Is my video... It's working fine right over here. I don't know why. I think so it was lacking. Is my video all right? Please let me know. I think so my video was lagging. Is this working right now? Is my video working right now? Please let me know. Is my video working right now? Please let me know, guys. Let me know up till where were you able to hear me properly, so that I'm able to repeat if some of the part I was not able to tell you guys correctly. Up till where was I able to speak correctly? Up till where were you able to listen to me correctly? Please let me know, so that I am able to repeat from where you were not able to listen to me properly? Or was everything audible to you guys? Please let me know, guys. Were you able to listen to everything, guys? Please let me know. Everything was audible. Okay, great. So, are you guys able to understand like these neurons when bunched together in layers, and when there will be multiple layers, there will be like 15 or even 20 layers of neurons. Each of these neurons would be having like each of these layers would have like almost 1,000 neurons inside of each other. Each of the neurons have its very own function. So how complicated everything becomes mathematically, and what the neurons are actually thinking right now, nobody knows. Okay, it becomes that complicated at the end of the day, because of all the different activation functions, all the different formulas that is currently there, all the input output, whether one neuron is working or not, that would also make a lot of differences. Okay, so are you guys able to understand why these ANNs were so powerful? Why these ANNs were so damn powerful at the end of the day? Now the problem with this was that back in 1950s, although they were able to find this, that this is so powerful, but the hardware that was at that particular point of time that was currently there wasn't like that was shit. Okay, that wasn't a very good hardware. Right now your phones are more powerful than the greatest supercomputers at that particular point of time. So due to the lack of innovation in technology and hardware, they were not able to use these neurons practically. They were not able to use deep learning practically, and they decided that it was not a problem with the hardware, but a problem with what they had studied, what they had researched. So they scraped off neurons for almost 40 years. In 1980s to 1990s, people started again when the technology caught up with the paper itself, that is the research paper. Then the research and the experimentation began. Today you are able to use, if you are training a particular machine learning model using CNNs or ANNs, it usually takes 24 hours at the bare minimum to train a good quality model using the most advanced GPUs as well. So you are able to think that why people left, why researchers left researching about ANNs and CNNs for the past 50 years. Okay, but now today, due to the help of Google Colab, due to the help of like the hardware that is there, okay, you are able to understand these concepts and use it and experiment it yourself from your homes, from your own mobile phones as well. So that's the beauty of it. Now, although ANNs were used for both, like in the initial days when we didn't knew about CNNs, ANNs were used for like input data as well, where the input data was an image. Okay, so for example, what is an image? Let's try to first understand that. Okay, an image is nothing else but an matrix. So how many guys know that an image consists of pixels? An image consists of pixels. Okay, if you are zooming into a particular screen very closely, you will be able to see rectangles in on your screen itself. Each of those rectangles are called as pixels. Okay, each of those rectangles are called as pixels. Okay, and your image as well is nothing else but pixels that are currently there. Each of these pixels have three values: red, green and blue. Each of these pixels have three values: red, green and blue. So mathematically every picture can be represented as a three-dimensional array, a three-dimensional matrix. Okay, that will look something like this. Let's say that it's a 3 by 3 or a 4 by 4 image. Okay, 4 pixel by 4 pixel image right over here. Okay, so this particular image is 4 pixel by 4 pixel. The first will have the red channel, then there will be another one that is your, there will be a depth of 1. Okay, that will be your blue channel. So it will be of 3 depth. Okay, let me just create this. So this is how it will look. It will have a width of 4 pixels by 4 pixels, that is the height and width of the image itself, and then a depth of 3 pixels that basically represents the R, G and B values. Okay, the R, the G and the B values. Okay, so each image is nothing else but a three-dimensional image. Okay, a three-dimensional matrix. Now if you're having a black and white image, you're having a black and white image, you don't have 3 channels, you don't have 3 color channels like red, green and blue. You only have one channel, that is either it's black or it's white. Okay, so the black and white image is usually one dimensional in nature, but a two dimensional, basically it's a just a matrix. It's a like a it does not has any depth. Okay, it's just a matrix, a plain matrix. So black and white image is a plain matrix itself. A colored image has 3 layers, R, G and B. When we'll be making the project, you will be able to see that. So for example, a black and white image would just have like two, either it is black or it is white. You don't have anything in the middle. You don't have any other color. So it is a one dimensional, it's like two dimensional matrix. Okay, having just the height and the width of the image. That's it. Okay. Okay, great. Now in case of, so let's not go into colored images. We'll now deal with just black and white images so that you are able to understand it correctly. Now when they were ANNs, okay, when they were ANNs, what they did was to handle image data. So you are having an image, let's say that this is your image. Okay, it's a 4 by 4 matrix right over here. It has 16 different pixels. So they opened it. Okay, the first particular layer went right over here. This is the first layer, 1 2 3 4. The second layer went right over here on top of it, 1 2 3 4. The third layer went on top of it, again 1 2 3 4. The fourth layer went on top of it, 1 2 3 4. So what they did was they flattened the image. Okay, this is called as flattening the image. They flattened the image, and now these individual numbers, these individual pixel data, whether it is black or white, is now your input data for these neurons. This is how they used to handle black and white images using ANNs. Okay, this is how they used to handle black and white data as an input to your ANNs itself. Are you guys able to understand this? Please let me know. Are you guys able to understand how I flattened the image and used this as an input itself? Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Guys, are you able to understand this? Please let me know, guys, how I was able to flatten the image and use it as an input for my ANNs. There are 100 of you and only 4 or 5 are saying yes. Guys, are you able to understand it or not? Please let me know, guys. Okay, so now, but this was not very like efficient. Okay, like ANNs were not built for handling image data. Okay, that was the major case. It was not able to find details on the images because now the image does not look the same. It has been flattened out. It's not the same image. It's totally different. So ANNs were not like very efficient. Okay, ANNs were not very efficient on image data. Therefore came the era of CNNs. Okay, therefore came the era of CNNs, or convolutional neural networks. Okay, convolutional neural networks. What the basic idea for convolutional neural networks is, you don't have to flatten an image. Okay, flattening an image basically means that you are destroying the like relationship between the pixels themselves, flattening the image, because an pixel that is right over here, the surrounding pixels have a lot to influence on that particular pixel itself. So it's very difficult. Okay, it shouldn't be flattened out. That was the major concerns with CNNs. So what CNN does was, okay, so you are having an image right over here. Let's say, let me create an image. You're having an image right over here. Convolutional neural network said that, okay, what is better, to spread it out individually into a single layer and then go over it? Is that what is important? Okay, to spread all these pixels into a single layer, will you be able to identify the image? No. If this was an image of a cat, and instead of providing you like an image, a matrix, I provided you a row of just pixels attached to each other and showed you that, okay, what is this? Will you be able to identify it? No, your brain won't be able to identify that image. So what he said was that, you guys, okay, you guys look at small portions of the image at once. Okay, you will look at this particular part of the image. Okay, so for example, this is an image of a let's say a cat, okay, or a dog. Okay, let's draw a dog right over here. Hello. So you are looking at a dog right over here. Okay, he has eyes and then a body and a tail right over here. Okay, so it looks like the dog is saluting you, but I guarantee you that that's a tail. Okay, so what he said was, you look at small boxes. Okay, you look at four boxes right over here. Then you move on to the next four boxes. Move on to the next four boxes. So just take out any image, blind yourself like this, and go over small portions of the image. You will be at once you will be able to see an eye. At once you'll be able to see a nose. At once you'll be able to see a ear. At once you'll be able to see a tail. And you will be able to identify that, okay, yeah, so this looks like a tail. Okay, this looks like a nose. It looks like teeth. I think so this is an animal. Okay, this looks like a ear. Okay, this ear looks like the ear of a dog. So you will be able to classify without showing you the entire image. I'm just giving you some boxes of the image itself. You will be able to identify that, yes, this is a dog. Okay, so that is where convolutional neural networks come into place. Convolutional neural network says that instead of flattening it out, divide it into small images. Take this particular image first of all, then this particular image as the second image, this particular image as the third image, and so on and so forth. Now what would you, so are you guys able to understand these boxes? Why I'm saying that these boxes are important? This is a core of convolutional neural networks. These boxes are the core of convolutional neural networks. Are you guys able to understand it? Please let me know. Are you guys able to understand it? Guys, please do let me know. Okay, so now what would it do with these boxes? So what it says is, I will, first of all, I don't want to increase the complexity of my like program. Okay, I don't want to take my program, I don't want it to take like years to complete. Okay, so usually your images are of the size of like 180 pixels. Okay, 1080 pixels by 720 pixels. So these are huge images. These are huge images. I don't want such huge images at the end of the day. I want images that are like approximately 480 pixels by 480 pixels big or something like that. I don't want like these high quality images. My neurons will take a lot of time to understand this. So what they did was, they said that, okay, no issues in that. Instead of taking up are you guys able to understand up till here? Please let me know. Let me show you today's attendance link first of all. See, I understand that it's a bit like bit it's a lot for you guys as well, okay? But see, this is very important to understand it properly. It's really very important, guys. Today is the sixth day, I hope. Okay. D6, the responses are open. Send link. What a new Guys, please take a screenshot of, like, if you want to see the attendance thing, it is right over here. I will show the QR code as well. So tomorrow we are going to have a very long class. Okay. You guys can take a QR code for, like, you can scan the QR code and take a screenshot as well. Can you explain the open source corporations employment systems? Uh, See, they also work like normal corporates itself. Okay, there's not a lot of difference. You get paid like normal employees. You work on an open source system, and see, even if they're saying that it's an open source system, some of it is not open sourced. Okay, so that is the reason why. After completing a boot camp and submitting the project, I don't know. I think so. From this boot camp, you will be getting three certificates. Uh, One from MLSA, that is Microsoft, one from DSC, that is Google, and one from our end. So that will be three certificates, I guess. So keep today's session short. The rest of the theoretical portion of CNN will complete tomorrow with the class itself. Please be on time at 7 o'clock. We'll have the classes at 7 itself, and we'll have a 2 hours class tomorrow. The project will take an hour to complete, so I know that that won't take a lot of time. We will complete the theoretical portion of CNN and then the project. Okay, so please be on time, guys, tomorrow, and we'll have an awesome time learning. Okay, thank you so much, guys. Thank you.